Greetings and welcome to the module 10, tetramethylsilane as NMR frequency standard. The session's objective is to learn the use of tetramethylsilane as NMR standard. The session's outcome: at the end of the session, the learners will be able to explain the choice of tetramethylsilane as NMR frequency standard. We all know that the frequency is directly proportional to the applied magnetic field. If you increase the magnetic field strength, the frequency requirement for the resonance will be changed. Hence, we are using some internal frequency standard to avoid confusion. We have also discussed tetramethylsilane is used as a NMR standard, but the question rises why we are using that tetramethylsilane as NMR standard. Let us see why we are using this as a NMR standard. If you see the image of tetramethylsilane, that is the structure of tetramethylsilane, this compound is having 12 equivalent protons, that is chemically equivalent protons, and 4 chemically equivalent carbon. And we know that the silicon is electropositive, which pushes the electron to the carbon, and carbon again is electropositive, which directs the electronic cloud to the protons. Thereby, all the 12 protons present in the tetramethylsilane is highly shielded, and hence it gives sharp and strong NMR signal. Therefore, a small amount, approximately 1 to 5% by volume, is needed to get strong and sharp NMR signals in NMR spectrum. This tetramethylsilane is chemically inert. It won't react with any organic compound which is under study, and the tetramethylsilane is soluble in almost all organic solvents, and we know that organic solvents are sufficiently volatile, which will be easily removed from the sample after NMR spectrum has been recorded. Hence, the NMR spectroscopic technique is a non-destructive technique. But the tetramethylsilane is not a water-soluble compound. Hence, for aqueous work, commonly used internal frequency standards are sodium 4,4-dimethyl 4-silapentane sulfonate. It is represented as DSS, or the deuterium substituted carboxylic acid salt. The structure of the compounds are given in the slide. Hence, this make tetramethylsilane to use as a NMR frequency standard in NMR spectroscopy. We cannot use any compound as a NMR frequency standard, but any compound having these characteristics can be used as the NMR frequency